recording now. So this is going to be, I'm going to start off by talking about how to create a GitHub repository and upload a Godot project to it. Then we'll cover some other things like sound, navigation meshes, and the XR tools plugin. So in order to make a GitHub repository, the easiest way to do it is through the GitHub desktop app. So if you have the GitHub desktop app on your, I'm sorry, I just started pulling it from the internet, so we're just going to wait a minute. Great, okay, there it is. So if you want to create a new repository, just click on these repositories up here, and then click the Add button, and then you can either clone an existing repository, so that's copying one that you already have. So if you've made it online already or on a different computer, this is how you can get it onto to a new computer. Or you can just create a new repository. So I'm going to create a new repository. You pick the name of it. So I'm going to say like, I'll go ahead and call this SVA Final Project GitHub Demo. So this is just the name of the repository, and then you pick a place on your computer where you want to save it to. So I'm just going to want to save it to the desktop. I'm going to go ahead and I'll give it a README. Why not? That's just a little file that describes what's in it. And then I'm going to go ahead and also give it a git ignore specifically for Godot. So this is going to help us ignore a bunch of the sort of invisible stuff that Godot uses that we don't actually need to share from computer to computer. So I'm going to hit create repository. And what you'll see now is we now have this empty sort of repository situation. We can click show in Finder, and it's going to take us to this folder, right? So here's the folder. This is the name of the repository that I just created. Here's our README file. It's just an empty file right now. I can give it some text. I'll say, this is my README. And I'll save it. And you'll notice that when I go back to GitHub Desktop, you'll see that there are some changes, right? You'll see that it says, hey, you've changed one of the files inside of the folder, right? Because again, GitHub is just kind of like a, GitHub is a file management system, basically. Is all it really does is it watches a folder for any changes in the folder, and it keeps track of those changes. So it can tell that I've changed this text file, and you can see right here, I technically deleted the first line and created a new line, and then added this is my README in the text of the file. So if I want to like commit those changes to the repository, I need to write a little commit message where I say like, if you only have one file changed, it'll just give you a nice little template you can use. So I'll just leave that. It'll say update README. I can add a description if I want. I added, in all caps, text. I'm excited because I'm in all caps. And then I just hit commit to main. And then the final step to actually get it, right? So there's a difference between Git and GitHub. Git is when it's is the thing that works locally on your computer, and GitHub is like the Facebook for Gits. So to get your code onto GitHub, you have to share it from your computer onto the internet. So you need to say publish repository, and this is going to take your repository and share it up to the cloud. So I'm going to click publish, and then it's going to give me a chance to rename it if I want, give it a description. And then I can choose to either keep it private or make it public. If you're turning stuff in for your final project, please make it public. It'll be a lot easier for me to grade that way. Otherwise, you're going to have to invite me to it like we did, like how I invited you for the pattern language repository, right? That was kind of a whole process we had to go through. So if you want to skip that whole process, we just make the code public. So uncheck this box and then click publish repository. And now if we view it on GitHub, we'll see here it is. Here is the code on GitHub. Here's the file. And there's technically 3 files here. There's a git ignore file, which has some specific Godot stuff. And then we have our README file. So this is all our repository is right now, okay? Now, in order to actually get a Godot project in there, all we have to do is create a project inside that same folder, right? So we have this folder here where our project is. So in order to create a new Godot project, I'm just going to open up Godot. And I'm going to create a new project. I'll call it Final Project Demo. And I'm going to find the folder. The important part, right, is you need to save the project into this specific folder on your computer. So what you want to do is hit browse. You want to hit browse, and then I'm going to go to desktop, and then I'm going to look for it. I think I called it, this looks like it, so I'm going to double click this and hit select current folder. It's going to warn me that the path, the folder isn't empty, and it's like, hey, are you sure you want to do this? Yes, I do. The only thing that's in that folder is the README file. So that's going to be fine. So I'm going to hit create and edit, and it's going to make sure that I want to do this. I'm going to say yes, that's fine, no problem. And now we have a little project file. And we have a Gato project in our folder. And you'll see, right, we have our icon.svg in this resources folder. And if I go back to GitHub, you'll see that a couple things have been added. We have added the icon SVG. So here's this little robot. This is the actual code for the robot image. This is the file that Gato uses to import that image into itself. And then this is our project.gato file itself. If I want to make a scene, I'll just make a scene real quick. I'll call this main, right? This is all pretty boring at this point. Just add a camera. And I'll save this file and save it as main. And I'll run the project, and I'll select the current scene to set the main scene. Right now we have like a very basic do-nothing project. And you'll see if we go to GitHub, a couple things have been added. We've added a main scene. And look, this is the code that is in the main scene. It just has, it says what the main root of the node is, or what the root node is. It's a node, oh my God, a node 3D. And then it also says we have a camera 3D. And then in the project file, we've changed the project file to also include the main scene, which should be somewhere. There it is. Main scene is the scene that we called main. So then all I got to do is commit this, so I can say created Gato project, and then hit commit, and then push. And then if we go back to GitHub, the website, and we refresh, you'll see that there's a bunch of stuff there. So here's our project. And then the final thing, if you want to turn this in, all you need to do is just take this link, copy it, and submit it via Canvas, right? And that's easier in some ways than having to like zip up your whole project and upload it to Canvas. And what's nice about this too is, right, if you want to use a different computer, right, all you need to do is clone the repository by just going to, you can click, like if you do this on the school computer and then you want to move it to your laptop or whatever, you can just on your laptop click open with GitHub Desktop, or on the GitHub Desktop app, you can just kind of go, add a new repository, clone a repository. I wonder if I can clone it twice. Let's find out. I'll say final project GitHub demo. Yeah. I'm going to clone it to a different folder too, and we'll clone it. And now I've actually pulled it down off of GitHub into another folder right next to the original one, right? So here's the original one, here's the new one, and if I change any of them, right, if I deleted the README, for instance, hit commit and push, right, so let's pretend I just did this on the school computer. Now let's pretend I've opened up my laptop. I'm going to go to my GitHub repository. I just fetch the origin. We see that there's a change, and then I pull it from the origin. And now if we view it in the Finder, we'll see that we've also deleted the README over here. Okay, so that's basically the workflow for uploading and saving stuff to GitHub. Does that make sense for folks? Yeah. Any questions? Again, you don't have to do it this way. It's somewhat easier for me, and I hope it's a little easier for you. But also, if you really want, you can probably just like take your folder, compress it into a zip file, and then upload this zip file into Canvas. Sorry, I teach at two schools, and one school uses Canvas and the other uses Blackboard, and I was getting mixed up. But you could also upload stuff that way. Okay? Any questions? Is that a question? No? Cool. So that's GitHubby stuff. Sound, yeah? Should we do sound real quick? So for this, I'm going to switch back to the syllabus repository. and I'm going to, right, and again, if you want the syllabus code, the easiest way to get all the examples and stuff from the syllabus is to clone the repository yourself, and then you actually just have the files, right? So again, if you're doing that for the first time, all you need to do is go to the syllabus, hit code, click open with GitHub Desktop, or you can copy this link if the desktop thing doesn't work. You can also just download the zip. So this will just download a zip file of the current state. But when you clone it, that's how you can get the latest and greatest version sort of synced up. So let's say you write, copy all the files, go to GitHub, click add, clone repository, go to URL, paste in the URL, and then pick a folder on your computer, and then just hit clone. I'm not going to do that right now because it's kind of big at this point. It might take a couple minutes. But this is how you can get all the examples that I'm showing you in class and actually just use them directly in your projects. So here in the class repository, I have a resources folder. Do I already have a sound demo? Looks like I don't. So I'm going to go ahead and make a new project. I'll call it sound, and this is just going to be in the resources folder. I'm getting confused. Yeah, okay. In here. So now we have a blank project that'll live inside of this folder in resources. So sound is really straightforward to use in Godot. The first thing you need is a sound file, which the easiest type of sound file is a very famous file format, right? MP3s. We've got this Beethoven or this Neon. Ooh, Neon is kind of exciting. So just drag and drop an MP3 from anywhere into Godot. And you'll see that when you drag it into your folder, it imports like this. It's got this little icon. Can everybody see? I always ask you my perennial question. Can you see good? Oh, that's worse. No, that's also worse. That's the same. Can anybody not see? Okay, you can all see. Right? We have this little MP3 file. If you double click on it, it'll show you some sort of import settings you have, and you can also preview it just by playing it right here. I hate that. So we're going to get a different MP3. I think I should have gone with Beethoven. That's a good choice. I believe this is from our pattern language. This might be yours. Was this the party time music? Yeah, nice. So we just have... we have an MP3 file. You can change a couple settings here. So again, to get here, all you have to do is double click on the file. And if, for instance, you want the file to play as a loop, like you don't want it, like this, this neon thing, this is probably a sound effect that you might have when something gets zapped. And you only want that to play one time. But if you have like a background track that you want to have play over and over again, you can just click loop. You can enable looping in the actual file itself right here. So you can do that to enable looping. You can also change things like, I think like the start time, for instance. Let's see. I don't exactly know what that did. You can change this mysterious thing called offset here if you want. It doesn't seem to tell us. The most helpful one is really looping, and if you need to edit your music files, I suggest using something like GarageBand anyway. So then when you've, if you want to if you're changing any of these settings, you need to click re-import. And now we have our little MP3 file. So now in order to play the sound, that's also pretty straightforward. All you need to do is add a node called Audio Stream Player 3D. And you just hit create. You'll see it has this little speaker, and it also has, it's a 3D node, right? So it can be positioned in space. And what's nice about that is it's inherently spatial. So the sound in the game engine comes from this point and emanates out like in a sphere around it. And the closer you are to this point, the louder it'll sound. And the farther away you are, the quieter it'll sound. If you want something to be globally loud, like always loud and not tied to space, you can use a different node that's just called Audio Stream Player. And this one is not 2D or 3D. This one will just play music at the same volume wherever you are in space, okay? But for this one, right, Audio Stream Player, all you need to do now is to take the MP3 file and drag it into the resources section of the stream itself. So you just take it and drag it and drop it. You can also set a couple of parameters here, right? You can set whether or not it's automatically playing, for instance. You can set how loud it is. You can change the pitch, I believe. And now if we were to run the scene, I'll just set this as the main scene. We actually can't hear anything. Does anybody know why we can't hear anything?
Get something to play it.
So we have something that's playing it, but what did you say? Camera, yeah. So you need specifically a camera 3D, right? Because we used the spatial audio node, we have to have it in relationship to a camera. A camera by default. There's also another node we can use to listen to it. Huh? Audio Stream Listener is the other one. So here we have a camera. So now I think if we play it, yeah, we can hear it. We've also changed the pitch, right? So I can go over here and change the pitch. Right? It's kind of exciting. You can do all sorts of fun stuff with that. You can pause it by hitting this, by enabling stream pause, and then I don't exactly remember how you start it. Okay. So again, right, it's important to remember that this is spatial, right? So if, for instance, I had, like, I'm just going to do a CSG mesh for reference. So we'll say we're right here, right, and we'll make the audio the child of the mesh. Here's the camera. I'm going to move it way far away and start the scene. Right, and you can't actually hear it. Oh, I guess you can hear it. But I'll move it further away, and you'll see it gets quieter. I'll move it closer, and it gets louder. So this is really good for something that's supposed to be spatial, right? Like maybe like a footstep or something. The final thing I can show you is how to make sound play automatically. Okay, so I'm going to add an audio stream player, or not automatically, sorry, with code. I'll show you two more things. First, I'll show you how to make the audio play with code. So I'm going to rename this like Zap, and I'm going to give it this horrible MP3 file. And if I want to play this code, does anybody have an idea of how I would do that? To like play this sound effect? First I need a script, right? So I'll just create a script. And I'll make it so that when I like, you know, when I press spacebar, if input dot is action just pressed UI accept. What do we think we need to have down here in order to like play the sound?
Would you drag in the zap and make like a variable for it?
So yeah, you just need to reference the node, right? So by dragging it in, or right, dragging it in just helps you do a little shorthand. You can get any node by just typing $, and then the name of the node. Right, so we have the name of the node. and this is the audio stream player. So like, what do we think we need to now do? We've like gotten it. What do we need to tell it to do?
Dot play or something?
Yeah, right. We just need to tell the node to like play the sound. So we can just say dot play. And this is a function, right? It's an instruction to go and do something. So we need these parentheses. And then now, if we play the scene, we have our music that's playing automatically. And if I hit spacebar, we have a zap effect. Cool? So that about covers it for sound. The only other thing I can tell you, or that I will tell you, is, well, okay, I can go even deeper on, there's more complicated, nuanced things you can do with sound. So does anybody want to learn even more about sound, or should I move on to other topics? And can we get this back? Okay, I'll show you one more thing. There's a node called Audio Stream Listener, and this overrides the position of the camera to be like where the sound is heard from. So for instance, right now I'll move it to like right here next to the sphere. And you'll see that it's nice and loud, even though the camera is really far away, right? And now if I move this away, it gets quieter. Cool. So that's a handy thing. And then the final thing, I promise, then I'm moving on, is that you can also select what is known as an audio bus. An audio bus is sort of like a mixer or an extra step you can do in order to add sound effects and stuff. So if you want to add things to if you want to add extra sound effects on top of this, what you can do is click on the bus. Nope. You need to click down on Audio tab down here, and you'll see that we have this this master bus, and this controls the sound for. This should control the sound for everything. Maybe you need to restart. Yeah, you'll see that it's super quiet now, right? And you can also add all sorts of effects here too. So you can add like a chorus effect. And this might need to be restarted. You can add like, distortion. And if you want to change any of those parameters, you just click here and play with these parameters and see how it sounds. Oh, wow. It's pretty hardcore. Dang. This is an epic sphere. Party time indeed. Yeah, any questions about that stuff? Cool. So that's audio. The next thing I'll show you is what's known as navigation meshes and navigation terrains. Ritu, you discovered this on your own. Do you want to talk a little bit about it, or like say like what is it and how did you find it? And
I found it on YouTube.
uh-huh.
Someone said that if you use the navigation mesh, it would just lead to like visible tracks.
Mm-hmm.
When you actually use it, and it's easier for people to know where they're going.
Mm-hmm.
It just displays it right there.
Yeah, that's totally right. And navigation meshes specifically are really good for getting like AI or non-player characters, NPCs, or enemies, right? Any sort of like agent that you want to have move around a space. It's how that you can. It's an easy way for these agents to know how to navigate space, right? And so the way it sort of looks like this, and the demo I'll show you works like this. You just hit play, and then we'll see we have this little cylinder moves on this line towards this dot, right? But we can move this dot around. Move it maybe over here or something. And you'll see now it kind of knows how to go over here. And it knows how to go around this thing, right? Specifically, I'll put the player behind... Oh, no, wait. That's going to be bad. Behind this thing. And it'll go, like, around that and around this guy. And this is actually pretty easy to set up. So, like, if you're having something where, like, somebody, you know, maybe hypothetically, I don't know, I'm making a project where, like, a floating baby head follows me down the street or something. You're welcome. This is how you do that, right? So, so it's pretty easy. You just sort of make a...
Recording this, right?
I am recording this, yeah. And I've also shared this code onto the GitHub, so you can also just copy it. What you want to do is just trying to think about the order of operations. I'm gonna like recreate it over here. So first thing you need to do is have a 3D scene, right? Then you want to have a light source and a camera. Okay, so I have a light and a camera. Then you want to create your level. So I'm gonna go ahead and create a node 3D, and I'll call it level. And then you want to like create any objects that you want to have inside of the terrain as like a child of these nodes, right? So I'm gonna sort of, and actually, sorry, what I'm gonna do is I'm going to, yeah, I'll do it this way. So you create a node called level, and then I'm gonna create some CSG shapes. So I'll do like a CSG box, and I'll make it nice and big. Then I'll just create some obstacles. Actually, as a matter of fact, I'll use the, I'll get some models for this too, because you can also just really easily use this with models. I'll use this restaurant bits plugin. I'll install that. But again, this will work with any models. I just like grabbing these models because I don't have to leave the engine. This is pretty big. That's very large. Probably delete some of these. We don't need a bunch of mustard. Okay, so now we have these restaurant bits. I'll get the GLTF versions. I'll take like, sure, a kitchen table. Okay, well that's gonna be a little big, and oh, it's just over there. Wow. Okay. Sort of wish it. There we did. Okay, we'll do it like that. Maybe like a kitchen counter. Sure. Of course, you're gonna, yeah, I don't know why it's not being smart about where to put it. That's okay. You just kind of drag it down. That's fine. You know, you could spend all day doing whatever sort of modeling you wanted. I'll also just add a couple of, well, what I'll do first is I'm gonna take these and move it to the main folder. And then I'm going to take this one and kitchen table A. Move that. Oh my gosh. Terrible way to do this. Move this to the main folder, and then I'm going to delete all these extra things because that's going to be pretty big. Okay, so so we have this scene. We have a couple of models. You can also add a couple of other CSG shapes, maybe like some cylinders or something. I'll make it nice and big. I'll duplicate it a couple times. Duplicate it like I'll take everything, I'll put it in here. I'll duplicate everything, rotate it. Oh God, I didn't need everything. I don't need this box. But maybe like, I did a silly thing. Why can't I duplicate it? All right. Okay, right? This is kind of a nicely complicated space. So you have all of your nodes as children of your root node, right? Then you need to have collisions turned on for all of them. So for the CSG shapes, I'll just use collisions. And for the kitchen tables, I am going to have to do something a little bit more complicated. I'm just going to need to, I'll make them local, and then I'll take the mesh and click on mesh and do create tri-mesh static body, and that's going to give it a collision shape. And I'll do the same thing for this. So I go to make local, and this just takes this takes the nodes in the scene and just brings them locally into this scene, so you can edit them directly. Then I click on mesh and do create tri-mesh static body. Okay, now we have a whole level with a bunch of little objects floating around in it. They all have collision shapes. So in order to actually make a navigation terrain, all you need to do is add a node called navigation region 3D. Then you need to give it a navigation mesh, right? This is kind of a classic error we have. We need to create the actual mesh. Then I'm going to take the whole level and make it a child of the navigation region. Okay, so you want all of the nodes that you actually want to have be like navigated in by your agent. You need to have them as children of your navigation region. Does that make sense? So then the final thing you need to do to make the region is just click on navigation region and then just click bake navigation mesh. And you'll see that it does this really cool thing where it like draws this whole terrain, and you can kind of see these white spots. These triangles, it cuts the terrain up into different triangles of like space that's okay to walk on, basically, right? So all of this, all the blue and green triangles are considered like okay areas for the AI to walk on. And all the white zones are areas it's not going to enter because it thinks there are walls there. And if you don't like the way this turns out, you can change these parameters in order to like shrink this size. But for the most part, the default is pretty good. So then, in order to have like something move through this terrain, I'm going to use this character body. I'm just going to copy and paste this into the scene, and then I'll show you how it looks. But all you really need to do is create a character body, add a node called navigation agent 3D, give it a collision mesh and a model, right? So I'll paste this into here, and then we'll take a look at this code and see how it looks. So basically, the code is fairly simple. Oh, and then I also have a marker 3D, which is going to be the destination, okay? But the destination could be anything. So this could be your position. This could be the position like of the XR origin, for instance, or the camera. But for this example, I'm just going to use a node called marker, which is nice because it's just like a 3D node that you can see. So there's the marker. You can see it. You usually can see it. Let's drag it up a little bit. There it is. I'll just put this marker like over there, okay? And so in this code, right, this navigation agent is going to, first we load in the navigation agent 3D, right? So we load in this child node, and we assign it to a variable. We do the same thing for the marker. We go and get this marker 3D. And we also have a speed. And then we also have a variable called arrived, which is false. In the ready function, all you need to say is, right, we reference this node, and so this node has this parameter called target position. And so this is going to be the position that the navigation agent is trying to move towards. And so you set this position to a position, and it can be, again, a position of a marker 3D. if you have a camera, you could say like, camera dot position, or you could say XR origin dot position. You can get the position of anything. A position is just a 3-digit number in space, or a vector 3, right? So once you set the position, then you just need to figure out how to move towards the position. And what the navigation agent does is it has this method called getNextPathPosition, which will give you the position that's next on the path that you want to use. And so you figure out the next position on the path, and then you just sort of assign a velocity to that position by sort of saying next position minus your current position is your velocity. And then you can normalize it and multiply it by speed in order to sort of slow it down or speed it up. Then you just set your velocity equal to that, and then you call the move and slide function. And when that works, demo. It just sort of goes. Wait, I think this is the wrong scene. What's happening? Maybe it's not the wrong scene. I'll make the camera a child of the agent. I will move it a little closer to the agent. I'm actually not going to do that. I'm just going to zoom out. That's pretty good. Okay. And I'll just run the scene. And there you can see it moves along the path towards the thing, right? And for all that complicated terrain I made, that's a pretty boring path. So we'll just try something a little bit more interesting. We'll maybe move it like into here, and we'll put the marker like maybe like over here. Try that. So there you go. It's like smart enough to like move around different obstacles. And you can change the speed just by adjusting the number that you multiply the velocity by, right? So we have this movement speed, so I'll make it like a lot faster. And I might not have exited. Yeah, there you go. We also have this path. That's a setting that you can turn on. So it's called debug. In debug, you can enable the path, I believe. But also if you disable it, then... Oh, no, this is the main scene, sorry. If you disable it, then we should not see the drawing path. So that's, the path is really good for obviously debugging it and figuring out what's going on. But then when you actually deploy it, you might not want to have your path visible. Although, maybe you do. Any questions about this?
Wait, so you can essentially have, like, I could have that follow, like, a person?
Yeah, so for instance, if you had like a character body, let's make a character now, like a character body 3D with a collision shape. I'm just going to do a simple like mouse and keyboard demo, but you could also have it with a exactly with yeah. Yeah, you just might want to, with the VR thing, I would maybe make it follow the camera, not the origin, because the origin stays stationary. Yeah. But for instance, we'll give this a collision shape. We'll make this shape like a capsule. We'll give it a mesh. We'll make this a capsule, because everything is capsules. I'm going to zoom in and put this up and over. And I'm actually going to delete this camera. And I'll make a new camera. And I'll pull it kind of up and back and down, down a little bit. Yeah, that seems fine. And then I'll just give it a script called character body. And this is just our default sort of character body template that comes built in with Gato, which is nice because then I can just use the mouse and keyboard to move around. And then what I'll do is in the agent, instead of going towards the marker, I'll just drag in the character body. Oops. Well, that's fine. You don't even need to have the export version. You can just say, let's see. Well, so you might want to change things slightly, right? Because this is just setting the target position once at the beginning. Instead, you probably want to set it every time. If you want the thing to be sort of constantly following you, you probably want to set it every time during the process function. So I'm going to move that down to the process function. And then instead of saying marker position, I'll just say character body dot position. And then now it should follow us. Yeah, you'll see, there it is. It's like, and it moves a lot faster than me, right? So it's it's always catching up. But if I change the speed back to like 1, then we have something that is kind of creepily following me. It's really, I'm quite alarmed by that, actually. I hate that. 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 I am leaving. I am leaving. I am leaving. Where's the fastest cliff? I wonder if it'll follow me off the cliff. I don't think it will follow you off a cliff because the navigation region ends here, right? So there's a little bit of safety there. But that's enough of that. Huh? Practice. But also, you know, I'm happy to help. So I will share this video and this code, and hopefully we can get something working like that in your projects. Okay, it's coming up on 420. Nice. Did anybody do anything fun for? I'll stop recording before we talk about 420. Let's see. We have the movement demo. Yeah, I'll also show off the movement controllers, I guess. It's a little hard to demo today because one of the biggest barriers, as we've talked about, is getting the stuff from these specific computers onto the headsets. But I can show you what it looks like on the computer, and then I can show you how it works on the headset itself. I just can't. I don't think I can show you the act of actually putting it onto the headsets. But if you have any questions on how to do that, reach out and we can get you set up. The thingamajig, the code that you want is here inside resources. We have XR movement example. This is a new project. You can open it on up. I will also show you, I guess I probably should show you how to do it from scratch, huh? That would be good. Is it helpful when I do things kind of from scratch, or yes? Okay, yeah. Then so I shall. This is what it looks like when it's all kind of said and done. Why don't we do this? Why don't we actually take a 5 now? Because it's going to take me like 5 minutes to get, or let's take a 10-minute break now. That's going to take me some time to get the headset set up anyway. And that way, when we come back, I can show it to you on the headset. I'll recreate this example, and then we can move into project time. Okay? All right, I'll see you back here at 4:30.